Hello, please consider this as your revision for the um, upcoming IA on this weekend. We're looking at quadratic functions right now, so let's set the ball rolling. A quadratic function is given by f of x equals ax squared plus bx plus c. Could have also written it as y equals ax squared plus bx plus c. So for a quadratic function or equation, the highest power of x is 2. Y here represents the function. It's the same thing. Now, when you plot a graph for a quadratic function, you can get either a minimum curve or a maximum curve. Minimum curve means your a is positive, is greater than 0. Maximum curve, a is less than 0, is negative. So, positive people are always smiling, negative people are always frowning. We are good to go. Let's look at square root property. If you have a squared equals b, and you are making a the subject, a will be equal to plus or minus square root of b. This is because let's say b was 4, you could have taken positive 2, you square it. You could have also taken negative 2, you square it, you get also 4. So we are good with this one too. Then we move straight to completing of squares. How do we complete the squares for a quadratic function? F of x equals ax squared plus bx plus c. We want to complete the squares. So make sure that the coefficient of x squared is 1. So we can factorize out the a. If I multiply through by a, I'll get this. Now you look at the coefficient of x, which is b on a. Find half of b on a. You are going to get b on 2a. Now what do we do with it? You have to add and subtract the square of it. So it looks like nothing happened. So b on 2a, you square it, so you add it. Now let's intentionally subtract it again, the square of it. So it looks like we didn't do anything at all, but then we did it on purpose. So if you look at this very carefully, it looks like someone we already know. If you have a plus b all squared, ignoring the long way, just square the first value, this times this, you get 2ab, then you square the last one, b squared. Similarly, if you add a minus b all squared, you square the first one, a squared, 2 times a times minus b, minus 2ab. You square minus b, you get positive b squared. So if you look at this is just x, and you look into the bracket, what is here is a positive sign. So plus b on 2a all squared. Square this times this, you get that, then you square that. That's all. Remember your a was outside. It's very nice to write positive numbers before negative ones, okay? So let's expand this b squared over 4a squared. We're almost done with completing the square. X plus b on 2a all squared. Our LCM is going to be 4a squared. 4a squared divided by a will give us 4a, right? 4a squared on a. One of the a's will cancel out. So we have 4a multiplying c, 4ac minus this divided by that is 1 times b squared. We get b squared. We are good to go. This is 1 unit, so it's okay for it to be in a bracket. Now let's multiply back with our a. So a is going to multiply the first bracket. We get this. Then the second bracket, we get that. So this is our function. We have completed the squares. So when this a multiply this, it's cancelled as one of the a. That's why I see 4a here. Now let's get back to this. If you plot the graph and you had this, okay, this is a minimum curve, right? So where does the minimum value occurs, it's on a y-axis, so it occurs here. and at which value of x, you just trace it here. So this point is called the turning point, or the vertex, or the turning point. Yeah. Also, a line passes through the turning point and it bisects or divides this curve into two equal parts. So it's called a line of symmetry. To get the equation of line of symmetry, or the value of x, as you can see here, you trace to x, the value of x at which the minimum curve, the value of x at which the minimum value occurs, we just equate this first bracket to 0. So x plus b on 2a equals 0. Your s is going to be minus b on 2a. This is called the value of x at which what the minimum value occurs, or the equation of line of symmetry. Now, how do you get the minimum value? This will give you your minimum value. Therefore, AC minus B squared all over 4A to give you your minimum value. So you use the two, whether it's a minimum curve or maximum curve, use the two. It works for them. Now, if we are to equate this to 0 and make x the subject, we are going to come out with x equals minus b plus or minus square root of what? B squared minus 4ac all over what? 2a. We will come out with this, and this is our general quadratic formula to solve any quadratic equation at all. So that's completing the squares. So I hope now we can all solve a question using method of completing of squares. So let's take an example. Once you use completing of squares to solve this equation, 3x squared minus 2x minus 1 equals 0. I want to make sure that the coefficient of x squared is 1. So here, because it's an equation, you can just divide through by 3. You see, it's an equation, so you can just divide through by 3. Then after that, the coefficient of x is what? Is negative 2 over what? 3. Find half of it. You are going to get what? Negative 2 over what? 6. So x squared minus 2 over 3x. So you add negative 2 over 6, the square of it. Then you are going to subtract again, negative 2 over 6, the square of it. Then minus 1 over 3 equals 0. So this side, you take your x, then watch into the bracket. Which sign is there? It's negative 2 over 6, so minus 2 over 6, all squared. So you can bring your equal to, meaning you send all this to the other side. Good. So sending this one there becomes 1 over 3. Sending this one there becomes positive. This is being squared, so that will be 4 on 36. Calculator will give you this answer. Let me check it out. That's 1 on 3 plus 4 on 36. So I have 4 on 9. So this gives me 4 over 9. I have x minus 2 on 6 all squared. Then we are going to use a square root property, right? So we know that x minus 2 on 6 equals plus or minus square root of 4 on 9. So from here, x will be equal to 2 over 6 plus or minus 2 on 3. So you come out with the plus. When you're done, then you do the same thing for the minus. I'm going to take your calculator and check 2 over 6 plus 2 over 3. You get your first answer. Then you come and do 2 over 6 minus 1 to get a second answer. So that's all. I think we can survive that. So we know how to use completing of squares to solve a quadratic equation. What if they ask us to use completing of squares to find the minimum value and then the value of x at which it occurs? For example, f of x equals 3x squared minus 2x plus 1. Find the minimum value and the value of x at which it occurs. Why are they asking us minimum value? Because a is positive. You say if a is positive, get a minimum curve. Positive are always smiling, and it will look like this. So let's see. Quickly, you have that, and then you find half of this. So that's minus 2 on 6. So you're going to add it the square of it and subtract the square of it, right? And plus 1 on 3, your 3 outside here. Then when you're done, this will give you something like x minus 2 on 6 all squared. You watch here and you watch that sign there. It comes here. Then compute. It's a computer. Calculator will give you this. So that's going to give us 1 on 3, yeah, minus 4 on 36, 2 on 9. We can multiply through by our 3 now, right? So we have 3 into bracket x minus 2 on 6 all squared, then plus 2 over 3. So what is the minimum value? 2 over 3. At which value of x does this occur? We equate the bracket to 0. It occurs at s equal to what? 2 on 6. So s equal to 1 on 3. Reduce to the lowest term. What is the turning point? The x value first, the y value. The turning point is 1 over 3, comma 2 over 3. We are good to go. Same as the vertex. Equation of line of symmetry. 1 on 3. So we are done with that. Now let's look at roots of a quadratic equation and quadratic that lead us to quadratic inequalities. Okay, let's look at this one first. For the roots of a quadratic equation, when you solve a quadratic equation, you get two answers, x1 and x2. So those are the roots or the zeros or the solutions. So if the roots or the zeros or the solutions of a quadratic equation are alpha and beta, then how do you find the equation? The equation is given by x squared minus into bracket sum of roots. You sum them, sum of roots x, then plus product of roots, you multiply them, equals 0. So if a quadratic equation has roots 2 and 3, then the equation will be x squared minus that's 2 plus 3, so 5x, then 2 times 3, 6, equals 0. You found what? The quadratic equation. However, you have to know some symmetric functions. For example, the sum of roots and the product of roots. Sum of roots alpha plus beta, and then product of roots alpha beta. You can define this in terms of what? The a, b, and c. We know a quadratic equation is given by a quadratic function is given by ax squared plus bx plus c. So we can define the sum of roots and the product of roots using the a, b, and c. Yeah, so our alpha plus beta, which is the sum of roots, will be given by minus b over a, and then our product of roots alpha beta will be given by c on a. So we can take an example for this and then we try and solve it. So let's say if alpha and beta are the roots of the quadratic equation x squared minus 2x plus 4 equals 0, we want to find another new equation whose roots are alpha squared and beta squared. So first of all, from the original equation, we can find our alpha plus beta. So alpha beta is equal to minus b on a. So minus our b is negative 2 on a is 1. So we get 2. And our alpha beta is c on a, 4 on 1, we get 4. Take note, our a here is 1, our b is minus 2, and our c is 4. So now, this is the new equation has these roots, alpha squared and beta squared. So we are going to take the sum of roots alpha squared plus beta squared. But how can we get alpha squared plus beta squared? We only have alpha plus beta and we have alpha beta. This is what we have here. But how can we get this? So we need to know some symmetric functions. So let's take, anytime you need alpha squared plus beta squared, this can give us something similar. We are expressing it in terms of sum of roots and product of roots. So this will give us the correct answer, because if we expand this, we are going to get alpha squared. We square this time that. plus 2 alpha beta. We square the last one. Then this came. So you can see this is neutralizing this, leaving our alpha squared and beta squared back. So this is exactly equal to this. And in this, you can see your sum of roots and product of roots. So this is called a symmetric function or a symmetric equation. There is symmetry, whatever is on the left, whatever is on the right. And then we also know difference of two squares. This will just give us alpha plus beta multiplying alpha minus beta. Yeah. But we don't even know alpha minus beta because we have sum of roots and product of roots. We don't have this. So we can derive that one to alpha minus beta all squared. Um, so this is what we do. We just take alpha plus beta all squared, then minus 4 alpha beta. So please keep this, that, and that. So let's check the symmetry for this one too. Let's expand this. We square the first one, then this times this times this. So that's 2 alpha beta. Then we square the last one. Then let's bring our minus 4 alpha beta. So what happens here? This and this, it will give us alpha squared, then minus 2 alpha beta, then plus beta squared. And if we had expanded this, we'll get the same thing. We square this times this, we get that. Then we square that. You see? So keep this, that, and that. All right, back to the question. This is our quadratic equation. It has roots alpha and beta. We want to find a new quadratic equation whose roots are alpha squared and beta squared. So from this one, sum of roots alpha plus beta will give us what? Minus b on a, and then we had 2. Product of roots will give us c on a when you had 4. Now, the new equation, the sum of roots for the new equation will begin by alpha squared plus beta squared, and the product of roots for the new equation will be alpha squared beta squared. So for the first one, we already established the fact that this will give us what? Alpha plus beta all squared minus 2 alpha beta. So we just substitute. What's alpha plus beta? As we found here, it was what? 2. Alpha beta was 4. So this will give us, let me write it down here. This will give us 2 squared minus 2ab. So 2 multiplying 4. So 2 squared is 4. 2, 4, 8. So we have 4 minus 8. So we get negative 4. And alpha squared beta squared is just the same as alpha and beta all together squared. So alpha beta here give us 4. So we have 4 squared, which is 16. Now we know the product, sum of roots and product of roots for the new equation. So x squared minus sum of roots. Our sum of roots is negative 4. So sum of roots x, then plus product of roots equals 0. So x squared, this becomes plus 4x plus 16 equals 0. So this is our new equation. I think we can all solve that. Now the very last thing we'll talk about under quadratic functions. We said that the general formula is to get the value of x. X is equal to minus b plus or minus square root of b squared minus 4ac all over 2a. Good. Now, whatever you see under the square root here, we call it the discriminant. So d, our discriminant is what? B squared minus 4ac. Now, pay attention over here very well. When you plot the graph, you can have variations. So let me just use a minimum curve to illustrate. We have this, we have this, yeah, we have something like this. So let's see. Over here, the curve is cutting the x-axis at 2 different points, but here it's touching it at only 1 point. Here it's not touching it at all. So here, if you are not touching the x-axis, we say that what? You have complex roots. We spoke about the roots. The roots are the answers or the solutions you get when you solve a quadratic equation. So you trace those roots on what? The x-axis. Those roots are what? Real numbers. You see real numbers on what? The x-axis. So you see here, this curve is not touching the x-axis, so it's complex roots or it has imaginary roots. Imaginary or complex roots. The roots are not real. But here they are real, but just that you are getting only one. But you should get two answers, right? Yes, meaning here you are getting repeated roots. Over here, yeah. So we have repeated roots. So if the answer is 4, you get 4 and 4. But here if it's 2 and 3, they are different roots. So here, the roots here, they are real. Here too, they are real. But just that here, they are real and what? Equal. But here, they are real and what? Distinct. Or they are real and different. So that's the difference. But we use the discriminant to determine, check all these things. And there's a tricky question they mostly ask in your IAs and exams. Yeah, your IA, because this will only come in your IA. They will ask you that find the value of x for which let's say the quadratic equation is always positive or is always negative. You should be careful with that. We'll look at it very soon. So if your discriminant here, you are given the equation um, or the function a squared plus bs plus c, you can get your a, b, and c from it. So you can find, use your calculator to compute the discriminant. After finding your discriminant, check, is your discriminant equal to 0? Is it greater than 0? Is it less than 0? So now, if your discriminant is less than 0, where are you? Imaginary roots or complex roots. The curve is not touching the x-axis at all. If your discriminant is what? Greater than 0, what does it mean? It means that what? You have what? Two real and different or distinct roots. If your discriminant is equal to 0, you have what? Two real and equal roots or repeated roots. So what if the question asks you real roots? You see here, real and distinct, here real and equal. So both here and here will give you what? Real roots. Since these two will give you real roots, we can merge them together. So for real roots, then we can see that the discriminant is either greater or equal to 0. So this is real root, complex root. So this is what? Real and what? Distinct. Two real and distinct. But this is what? Real and equal. Two real and equal roots. Now let me talk about the always positive or always negative. If they say a quadratic equation or function is always positive or always negative, what does it mean? Let's see. So we use the x-axis as reference point. If it's always positive, it's going to be like this. Look like this. It's always above the x-axis, positive. I told you y is a function. So if the function is always positive, this is y, positive y, negative y. So always positive it will be here, but it will never touch the x-axis. Always negative, somewhere here. It will never touch the x-axis. And these are what? Imaginary roots, right? So if the question says find the value of x for which was the quadratic function is always positive, know that the discriminant should be less than what? 0. Then you solve it and go. So this will give birth to what we call quadratic inequalities. Quadratic inequalities. So let's solve one. I think this is the end. So let's solve a question on that. So find the values of k for which the quadratic equation kx squared plus 12x plus 9 equal to 0 has equal roots. So if this has equal roots, then we know that what? B squared minus 4ac should be equal to 0, right? So where's our b? Our a is k, our b is 12, our c is what? 9. So b squared, 12 squared minus 4ac should be equal to what? 0. So 144, 4 times 9 is what? That's, hey, I've forgotten 4 times 9. Okay, let me use calculator. Well, I think I remember now. 36. So minus 36k equals 0. So 144 equals 36k. So we are going to divide 144 by 36. What do we get? We get 4. So we've gotten the value of k for which this quadratic equation has equal roots. Then now let's take one more. So this didn't give us an inequality, did it? No. But let's solve the next two examples. You will come across that. Now I want to find the range of values of k for which the equation x squared plus 3x plus 1 equals kx. is positive for all values of x. Find the values of k for which this is what? Positive. So as if it's a quadratic function or equation is positive, the discriminant should be what? Less than 0. It means you are getting imaginary roots. So let's rearrange this. We can see x here, we can see x here. So let's group like terms. 3x, then this comes minus kx plus 1 equals 0. So we have x squared. I think we should factorize the x out. So now we have this. So b squared minus 4ac should be less than 0, since they said that the quadratic equation is always positive or is positive. So now, where is our a? Our a is 1. Always write this down so it doesn't confuse you. Your b is 3 minus k, your c is 1. So b squared, we have our b, right? Good. 3 minus k all squared. Then minus 4a, where's our a? 1. Our c is also 1. This should be less than what? 0. Good. So now we have to expand this, right? Yeah, we have to expand this. So this will give us 9. We square the first one, 2 times 3 times negative k minus 6k. Then we square the last one plus k squared. So minus 4 is less than 0. So you see we are getting another quadratic equation again. Let's rearrange this wall. So we have k squared minus 6k. 9 minus 4, that will give us plus 5 is less than 0. So you can easily use calculator to check the values here, right? You just take your calculator and you solve it. So um mode 5 3. Yeah, so my answers were 5 and 1. 5 and 1. So since I know I'll get 5 and 1 at the end of the day after solving this quadratic equation, it means that in the bracket was k minus 5 multiplying what? K minus 1 less than 0. So that when I equate this to 0, I get 5. Equate this to 0, I get 1. So now, how do I get the range of values of k now? So this is a function, the y, and it is less than 0. So you have to represent it graphically. So you come and draw this. This is your y. And then what? This function here is less than what? 0. So less than 0 is the which portion of y-axis is less than 0. This is your 0. This is positive y. This is negative y. So the part less than 0 is what? The part below the x-axis, right? Now check. What is the coefficient of k squared here? Your a here is 1, right? Meaning it's going to give you a minimum curve. Since you know you get 5 and 1 as your answers, you just have to trace that 5 and 1 somewhere here and draw your curve to pass through your 5 and 1. After that, we are going to shade the region to get a range. So good. How do you shade it? You know that this whole thing here is less than 0. So which part of this curve? The part below the x-axis, right? That's what you target. So this curve is here. The part below the x-axis between 1 and 5 is this region. So the range should be what? The shaded portion. But however, this wasn't underlined. It wasn't less than or equal to. It was just less than. So my answer is from here to here, but not exactly. It's not inclusive. So I have k is greater than what? 1. But then at the same time it's what? Less than 5. So I have 1 less than k less than 5. So k is greater than 1 less than 5. This should be my range. If this was underlined, here would have also been underlined, meaning 1 and 5 would be inclusive. But it wasn't underlined because the question said we should find the values of k for which the equation is always positive, meaning discriminant is less than 0. So one more question on quadratic inequalities, and I think I'm done. So these are the questions we solved when I was explaining. So I think we are left with just the number 5 or so. So let's look at the number 5. They said we should find the range of values of x for which x squared minus 5x plus 6 is less than or equal to 0. So what do we do here? X squared minus 5x plus 6 Okay, I think greater than or equal to, rather greater than or equal to 0. So let's solve this. Um, you can just use calculator to get the answers first. 1 minus 5, 6. I have 3 and 2, meaning if I have 3 and 2, it was supposed to be like this. So when I equate both of them to 0, I can get 3 or 2. So now what do I do? Let's plot it. We'll get 2 and 3. This is positive. A is positive, meaning minimum curve. Now, they said that what? This function here is greater than what? Greater or equal to 0. So the function is a y. Which part of y is greater than 0? We know the positive part. So it's a part of the curve above what? The x-axis. So it will be this side going and this side going. So that's the solution, the range I've shaded. So from here going, from here going. But it should be inclusive since they underlined it. So here my s values here will be what? Less than 2. Here my s values will be greater than 3. Since they are not enclosed together, I have to separate them. Unlike the first one, they are enclosed together. So they are like together, you see. But here you can see they are separate. So I can say that what x is either what less than 2 or x is greater than what 3. Sorry, less than or equal to, greater than or equal to. Inclusive since it was already from the question. So this is a recap on quadratic functions. Take note of the particular question we solved. If they say find the range of values of x for which the quadratic function is always positive or always negative, it means the discriminants must be less than 0. I'll send more questions and then I'll expect answers from you. Thank you.